want to do here is we want to ensure that it is continuous, and the concern is not going to really be the square root kx, because that will be continuous provided x is greater than 0, which it is, and then the x plus 1 linear function, that will be continuous. So the concern, in order to make this guy continuous, is going to be the split point, and the split point happens at 3. So we're going to run through the continuity checklist for x is equal to 3. So our first step, we look at f of 3. F of 3 is defined. It is when the square root of kx, so we will plug in x is equal to 3 there and get that it's the square root of 3k. Now, the second condition that we need is we need our limit to exist. So we need our two-sided limit. Now, because this function is defined differently to the left and to the right, we have to first look at the one-sided limit. So the two-sided limit needs to exist. So we want the limit from the left to be equal to the limit from the right. And remember, we're going through everything based on the split point of 3. Now, to the left of 3, our function is defined as the square root of kx. And we want that to be equal to the limit as x goes to 3 from the right, and in that case our function is defined as x plus 1. Now we want that. We don't know that we have that. So we put a little question mark here. That's what we're trying to get. Now if you just look at evaluating the left-hand limit, x is going to 3, so you would plug in a 3 for x. So you would have k times 3 underneath the radical. Over here, to evaluate the right-hand limit, you would plug in 3 for x and get 3 plus 1. So you have 4 is equal to the square root of 3k. Now, that is what we want, because if we have that, then that will ensure our two-sided limit does exist. So to solve this equation, we have a square root, so we need to undo the square root. We will do that by raising both sides to the second power, and that will give us 3k is equal to 16. And then to solve, we just divide by 3, and we get k is equal to 16 over 3. So by picking this k value of 16 over 3, this will ensure that the two-sided limit will exist. So this ensures that the two-sided limit exists, and you can actually show that that two-sided limit will be equal to the square root of 3k. And that again is because it ensures that, so it will ensure that the two-sided limit exists, and it will actually ensure that that will be equal to 4 for the two-sided limit. Okay?